Imagine a massive commercial terminal with hundreds of speakers, but instead of announcements, all you hear are ghostly voices and static. It's a high-stakes mystery. A phantom signal bleeding through high-impedance lines in a sprawling infrastructure. Most technicians give up when audio interference turns into a chaotic nightmare. But we thrive in the noise. We're here to show you how we hunt down these elusive signals, systematically isolating ground loops and fixing shielded cable failures, ultimately restoring total silence and crystal clear output. Our mission is to transform chaotic noise into pristine audio, reinforcing our reputation as elite infrastructure maintenance experts. We're going to dive deep into the world of troubleshooting audio interference in high impedance commercial audio systems, focusing on the insidious ground loop, the crucial role of shielded cables, and the power of balanced lines. This isn't just about fixing a hum. It's about mastering the science of high-impedance troubleshooting once and for all. First, let's confront the invisible enemy, the ground loop. What exactly is a ground loop? It's an electrical anomaly that occurs when multiple devices are connected to a common ground via different paths. This creates more than one ground connection path between two pieces of equipment, resulting in unwanted current flow through the ground conductor. The primary culprit is often a difference in electrical potential between separate grounding points. This frequently happens when audio equipment is connected to different power outlets, each having its own ground path. But it's not just about power outlets. Cabling, equipment interaction, and environmental conditions can also contribute to this disruptive phenomenon. The problem with ground loops is unmistakable. They introduce a low-frequency hum, typically at 50 or 60 Hz, into your audio signal. Beyond the persistent hum, they can cause general noise, buzz, and other interference in both audio and video systems. To identify a ground loop issue, simply listen for that characteristic hum or buzz in the audio signal. A key indicator is that ground loops are far more problematic when unbalanced audio feeds are used, precisely because unbalanced feeds utilize the ground for the actual audio signal, making them more susceptible to these voltage differences. So, how do we banish these phantom hums? The first and often most effective solution lies in using balanced connections, such as XLR or TRS cables. Balanced connections are inherently designed to reject common mode noise, including ground loops. Unlike their unbalanced counterparts, they do not rely on the ground for the audio signal itself, thus providing a cleaner, more robust connection. Another fundamental step is to establish a single ground point. This means connecting all your audio equipment to the same power strip or power conditioner. By doing so, you ensure a unified ground path, significantly reducing the risk of voltage differences that instigate ground loops. Audiophiles often swear by high-quality power conditioners or surge protectors that provide this common grounding, understanding its critical role in maintaining audio fidelity. When balanced connections aren't an option, especially with unbalanced connections like RCA cables, ground loop isolators come to the rescue. These inline devices are ingeniously designed to break the electrical loop, while allowing the audio signal to pass through unimpeded. For more robust isolation, we turn to isolation transformers, sometimes called hum eliminators. These provide galvanic isolation between components, effectively removing noise while maintaining signal integrity. The best isolation transformers even feature grounded shields between their two sets of windings for superior performance. Some equipment offers a convenient solution in the form of ground lift switches. These switches disconnect the ground pin, effectively breaking the loop. However, caution is advised if using a ground lift adapter. Ensure the equipment is otherwise grounded via another path to prevent safety hazards. A neat trick is to introduce a small resistor, about 10 ohms, into the cable shield conductor at the load end. This helps maintain a ground reference, even if the primary ground path is lifted. Beyond these direct solutions, a strategic approach to grounding is essential. Consider electrically isolating the metal casings of one device from another to eliminate the loop. For large-scale installations, implementing a star grounding scheme is paramount. This involves grounding all components to a single, central point, We interconnect all the metal chassis with heavy conductors, such as a copper strip, and then connect this consolidated ground to the building's main ground wire system. At just one single point, this meticulous approach prevents the formation of multiple ground paths. Cable quality and management are also crucial. Always opt for short, high-quality power and audio cables to ensure low impedance connections. Furthermore, meticulous cable management is key. Keep power cables and audio cables separated. This simple yet effective practice drastically reduces the chance of electromagnetic interference bleeding into your audio signals. And, of course, regular maintenance is non-negotiable. Periodically check your entire setup for any changes or loose connections that might introduce new ground loops. Now, let's talk about shielded cables. Properly shielded cables are not just a recommendation. They are crucial for protecting audio signals from a myriad of interferences and environmental noise. The shielding acts as a vital protective barrier, insulating your precious audio signals from external electronic interference. Without adequate shielding, even a perfectly balanced system can fall victim to induced noise. Other common culprits for interference include external connections. For instance, disconnect your cable TV or antenna coax. Cable boxes or TV antennas are notorious for creating ground loops. If the hum disappears after unplugging the coaxial cable from your cable box or TV tuner, you've found your source. The fix? A dedicated coax ground loop isolator. For turntables, ensure the ground wire is properly connected to the phono, preamp or integrated amplifier, and always use shielded phono cables specifically designed for handling low-level signals. To further purify your power, consider a power conditioner or AC line filter. These devices actively reduce or eliminate high-frequency noise from the mains, providing a cleaner power supply to your audio equipment. For truly critical applications, installing a dedicated circuit for your audio system can decouple it from other electrical devices in the building, providing an isolated power source that is free from the fluctuations in noise introduced by other appliances. From unlistenable distortion to flawless audio clarity, this is how you fix large-scale induction sources. We are tracing interference across massive terminal blocks, applying precise impedance matching and balanced line corrections to eliminate the hum that plagues commercial systems. We systematically hunt the phantom signals bleeding through high impedance lines by isolating ground loops and shielded cable failures. This technical audit transforms chaotic noise into crystal clear output, reinforcing our reputation as elite infrastructure maintenance experts. It's time to stop the bleeding signals and master the science of high impedance troubleshooting once and for all. Witness the step-by-step audit that separates the amateurs from the elite infrastructure experts.